Ivo Labbé of the Carnegie Observatories is co-author of a paper describing how astronomers have pushed NASA's Hubble Space Telescope to its limits and found what they believe is the most distant object ever seen. It is 13.2 billion light-years away, some 3% of the age of the universe, which puts it roughly 150 million light-years more distant than the previous record holder. The observations provide the best insights yet into the birth of the first stars and galaxies, and the evolution of the universe. The dim object is a compact galaxy made of blue stars that existed only 480 million years after the Big Bang. It is tiny. Over 100 such mini-galaxies would be needed to make up our Milky Way galaxy. The scientists were surprised to find only one galaxy, which means that the universe was changing very rapidly in early times. Previous searches had found 47 galaxies at later times when the universe was about 650 million years old, which means that the rate of star birth therefore increased about 10 times between 480 million years and 650 million years. This is an astonishing increase which happened in just 1% of the age of the universe. Astronomers don't know exactly when the first stars appeared in the universe, but every step back in time takes them deeper into the universe's formative years, when stars and galaxies were just beginning to emerge after the Big Bang. If the scientists could see another couple 100 million years toward the Big Bang, they'd see absolutely dramatic things like the building of the first galaxies. Detecting even more distant proto-galaxies will require two things. First, the infrared vision of NASA's James Webb Space Telescope, which is the successor to Hubble. Second, the next generation of ground-based telescopes, such as the Giant Magellan Telescope. These new facilities are planned for later this decade and will provide confirming spectroscopic measurements of the tremendous distance of the object currently reported. After over a year of detailed analysis, data taken in the late summers of both 2009 and 2010 positively identified the object. The data came from the Hubble Ultra Deep Field Infrared. These observations were made with the Wide Field Planetary Camera 3 just a few months after it was installed by a May 2009 Space Shuttle mission to the Hubble Space Telescope. The object appears as a faint dot of starlight in the Hubble exposures. It is too young and too small to have the familiar spiral shape of galaxies such as the Milky Way. Though individual stars can't be resolved by Hubble, the evidence suggests that this is a compact galaxy of hot stars that first started to form over 100 to 200 million years earlier in a pocket of dark matter. The protogalaxy is only visible at the farthest infrared wavelengths observable by Hubble. This means that the expansion of the universe has stretched its light to the very limit of Hubble's capabilities. Astronomers determine distance in the universe by measuring how much light from an object has been stretched by the expansion of space. This is called redshift value, or Z. Before Hubble, astronomers could see galaxies out to Z approximately 1, which corresponds to 6 billion years after the Big Bang. The Hubble Deep Field, taken in 1995, leapfrogged to Z equals 4. The addition of new cameras and instruments allowed Hubble plausibly to reach Z equals 10, or about 500 million years after the Big Bang. The Webb Space Telescope is expected to leapfrog to Z approximately 15, and possibly beyond. The very first stars may have formed between Z of 30 to 15, or 100 to 250 million years after the Big Bang. The research is published in the January 27th edition of Nature. This is John Strom for the Carnegie Institution.